Today we're talking about proving angle relationships. Last week we talked about proving segment relationships. And all the things that we did in regard to segment relationships apply to angle relationships. And so, like, we had the segment addition postulate. We're going to learn about the angle addition postulate. And, you had to add segments together or subtract segments from each other. You can do that same thing with angles. Okay, so all that we did with segments applies to angles. Now, our first postulate is kind of like that ruler postulate that we learned. We don't really use it a whole lot, but there's this one called the protractor postulate. And basically it says that, every angle has a unique measurement. Okay, each ray has a one-to-one relationship with a number between 0 and 180. So, like, if you let this bottom one represent 0, then this one's going to have a unique relationship with another angle measure. Okay, so this is like a 49-degree angle. Even though I give you guys leeway either way, it truly just has one angle measure. Okay, and so that's what that protractor postulate tells us. Now, our next postulate is the angle addition postulate. And it says that if D is in the interior of angle ABC, if and only if the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Basically what that's saying is that the whole is equal to the sum of its parts. So if I add this angle ABD plus this angle DBC, it's going to be equal to ABC. And the only thing I hate about the angle addition postulate is there's so many letters that you have to make sure that you get straight and in the right order. Okay? But ultimately what you're doing is, let's say this was angle 1 and this was angle 2. Okay, the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. And that's what the angle addition postulate is. Just like the segment addition postulate, but it's dealing with angles. All right, now, our next theorem is called the supplement theorem. And it says that if two angles form a linear pair, then they are supplementary angles. Okay, so let's say you get to a proof and you notice here that you have got a linear pair. You can say that angle 1 and angle 2 are a linear pair. And I can get that from the definition of linear pair. Once you've established that you have a linear pair, then this theorem says I can say that those two angles are supplementary. So I can say angle 1 and angle 2 are supplementary. And that is by this theorem, the supplement theorem. So you establish that you have a linear pair. Once you've established that, then you can say that those two angles are supplementary. Now, another step that you might take off of that would be the fact that, what does it mean to be supplementary? They equal 180 degrees. So once you've established it's supplementary, and if you needed to in your proof, then you can make this next statement. The measure of angle 1 plus the measure of angle 2 equals 180. And I get that from the definition of supplementary angles. And what I'm showing you here is that, when you're doing a proof, there's a certain order in which things have to happen. You can't go from the fact that angle 1 and angle 2 are a linear pair to that their measures equal 180. You have to first state that it's supplementary, okay? And then you can state they add together to equal 180, okay? So there's kind of an order of things that needs to happen. We have the complement theorem also, which basically is the same thing. I'm going to name this angle A, B, C. It says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. So let's say that you were given that angle ABC is a right angle. Okay, let's say you were given that. And then you look and you see that 1 and 2 make up that angle ABC. You could say that angle 1 and angle 2 are complementary. And that's by the complement theorem. And then, what do we know about complementary angles? They equal 90. So after that, once you establish they're complementary, then you could say the measure of angle 1 plus the measure of angle 2 equals 90. And that would be by the definition of complementary angles. Okay, So now we're going to go back to some real math. I think you'll like this problem. If angle 1 and angle 2 form a linear pair, and the measure of angle 1 is 3x plus 32, and the measure of angle 1 is 5x plus 12, find the measure of angle 1 and the measure of angle 2. Well, what do we know about two angles that are a linear pair? They're supplementary, right? Which means they add up to 180. So what I could do is add these two together, 5x plus 12 plus 3x plus 32, and that is going to be equal to 180. So we end up with 8x plus 44 equals 180. We subtract 44 for both sides, and 146, 136, excuse me, 136. Then we divide both sides by 8, and x is 17. Then we go back, and we find the measure of angle 1 and the measure of angle 2. Okay, so to find the measure of angle 1, I'm going to replace x with 17. And so if I did 17 times 5 plus 12, 17 times 5 plus 12, 97? Yeah. So the measure of angle 1 then is 97. And what could I do to find the measure of angle 2? Well, you could just subtract 97 from 180, right? You could take 17 and plug it back into angle 2 information. That would work too. Okay, and so you get the measure of angle 2 is 83. All right. Okay, our next theorem says that the congruence of angles is reflexive, symmetric, and transitive. And we talked about that on Friday with the congruence of segments. You know, we learned these three properties for equality. And then on Friday we said that it works for the congruence of segments. Well, they also work for the congruence of angles. You still can't add, subtract, multiply, divide, use substitution in the congruence mode, okay? But you can use these in either. All right, now, these next two theorems, I want you to put a star by them because they're very helpful, but people tend to forget about them. Okay, so these are important ones. And it's the congruent supplements theorem. It says angles supplementary to the same angle or to congruent angles are congruent. All right. So what's that saying is that if you have two angles that are supplementary to the same angle, those two angles are congruent to each other. For example, if angle 1 and angle 2 are supplementary, let's give them some values. If they're supplementary, let's say this one's 60 and this one's 120, okay? So if those two angles are supplementary and angle 2 and angle 3 are supplementary, okay, so if 2 and 3 are supplementary and 2 is already 60, 3 would have to be 120, right? So if this 1 and 3 are both supplementary to 2, then 1 and 3, their only relationship would have to be what? They have to be congruent to each other, right? Because they're both supplementary to the same angle measure, okay? So that's what this is saying. So then angle 1 is congruent to angle 3. Now, it works also if you have a pair of angles that are supplementary to another pair of congruent angles, okay? For example, I'll use different numbers so we don't get it confused with this one. Let's say if angle 4 is supplementary to angle 5, and angle 6 is supplementary to angle 7, and angle 5 is congruent to angle 7. So 4 is supplementary to 5, 6 is supplementary to 7, and then these two are congruent to each other. Well, what's going to be true about 4 and 6? They're going to be congruent too, right? Okay. So then angle 4 is going to be congruent to angle 6. It's just like this one, except they're supplementary to two different angles, but those two different angles have the same measure, so it's the same idea. We also have the congruent complements theorem. Oh, and before I do that one, you know, I told you last week that when you use a theorem or a postulate as a reason, that you can't just put the postulate number or the theorem number, right? But if it has a special name, you can use that name. And you can abbreviate, that's fine. So, like, if you were going to use this in a theorem, you could do congruent supplement theorem. That'd be sufficient. Okay, and so that way you wouldn't have to write it all out. Okay? All right, the congruent complements theorem works exactly the same way. And basically, if angle 1 and angle 2 are complementary, so let's give those values. Let's say this is 30 and this is 60. And angle 2 and angle 3 are complementary. So 1 is complementary to 2 and 2 is complementary to 3. Then what can you say about 1 and 3? They're going to be congruent to each other, right? Because if this is 30 and this is 60, if these are going to be complementary and this is already 60, then this is going to have to be 30. 1 and 3 are going to have no choice but to be congruent to each other because they're both complementary to the same angle. All right. So let's do a proof. Now, this proof can be done in about 3 steps, or it can be done in several. Okay? I'm going to show you the shortcut. All right. It says that angle 1 and angle 2 form a linear pair. Angle 2 and angle 3 form a linear pair. Okay? The picture here is not really all that helpful because you want to kind of go some different ways with it. But anyway, angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are a linear pair. That's a given. Now, because they're linear pairs, what do we know about them? They're supplementary, right? So that would be my next step. Angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. What reason am I going to use? Definition of what? No. Definition of linear pair is a pair of adjacent angles whose non-common sides are opposite rates. No. Good try. Definition of supplementary is you already know they're supplementary and you say that they add together to equal 180. Okay? The supplement theorem. Okay? And the supplement theorem says if 2 angles are a linear pair, then they are supplementary. So that is the supplement theorem. Well, if 1 and 2 are supplementary and 2 and 3 are supplementary, we can say that angle 1 is congruent to angle 3, can't we? What reason? Everybody always tries to use transitive, but transitive is 3 congruent steps. This is a supplementary step and then a congruent step, so it's not transitive. Remember, I told you that it's a theorem that everybody forgets about, and you need to put a star by it. Congruent supplement theorem. If you have 2 angles that are supplementary to the same angle, then those 2 angles are congruent to each other. So that is the congruent supplement theorem. Now, like I said, this one could be done in a lot of steps. What happens right here in this second step is that people try to say, okay, well, the measure of angle 1 plus the measure of angle 2 equals 180, and 2 plus 3 equals 180. That's fine. You can use that definition of supplementary angles. And they set them equal to each other. They do some subtraction, and you get there eventually. Okay, it's just several steps. This is a little bit shorter route to it. Okay. All right. Vertical angles theorem. Okay. In the vertical angles theorem, we already really know this. We've already stated this. Okay. If 2 angles are vertical, then they are congruent, right? Angle 1 and angle 3 and angle 2 is congruent to angle 4. I think I told you that the first week of school. Okay? But it's actually, there's a theorem, and they went and proved it and everything to show that. All right, so we can use it. And one thing that you need to do when you're doing proofs is, we've been learning how to look at what you're given and make all these conjectures, make all these statements from what you're given. But a second thing that you've got to do when doing a proof is that you have to look at the picture. And what can you get from the picture? You need to look for vertical angles because you know vertical angles are congruent. You need to look for linear pairs because you know linear pairs are supplementary. So in addition to looking at the given, you need to look at the picture and get information from there also. All right, so let's look at this next proof. And don't be having a heart attack on the time. I know that we've got quite a bit of work to do today. I am going to give you some time in class tomorrow, about 20, 30 minutes, okay? But I do expect you to go home and do work too, okay? All right, it says that DB bisects angle ADC. So DB bisects angle ADC. What can we get from that? DB bisects ADC. Angle 1 and angle 2 are congruent, yes? Okay, here's DB, and it bisects ADC, right? Okay, so from that, I get that these two angles are congruent, yes? Yes. Okay, yes. All right, that's probably all I can get from the given. Now, what I'm trying to prove is that 2 and 3 are congruent, right? I already know that 2 and 1 are congruent, okay? Okay, so we go to look at the picture and see if we see any vertical angles, and we see some, don't we? 1 and 3 are vertical, yes? So if 1 and 3 are vertical, they're congruent to each other. So if 2 is congruent to 1 and 1 is congruent to 3, what relationship are 2 and 3 going to have? They're going to be congruent by what? Now 1 and 3 are congruent by the vertical angles theorem. 2 and 3 are going to be congruent by what? 2 is congruent to 1, 1 is congruent to 3. No. Okay, let's write it down, okay? It's transitive, you're right. It's transitive, yes. Even though you guessed, it's transitive. Okay, let's write it down and I think you'll see it, okay? All right. You said definition of angle bisector. We got that 2 and 1 were congruent from that, okay? And then we got that 1 and 3 were congruent by the vertical angles theorem. So then we got to make the connection with 2 and 3. All right, so let's write everything down. DB bisects angle ADC. That's given to. All right, and from the given, I knew that angle 2 was congruent to angle 1. And that is from the definition of angle bisector. So that's what I got from my given. Then I went and looked at the picture, and you guys recognized that 1 and 3 were vertical, right? And we learned that vertical angles are congruent. So I'm going to say that angle 1 is congruent to angle 3, and that's by the vertical angles theorem. Okay, now everybody look. 2 is congruent to 1. 1 is congruent to 3. 2 is congruent to 3 by the transitive property, okay? Now, in your homework, especially on the second problem, you're going to use the transitive property probably twice, okay? The actual order is not perfect, but you can still go ahead and use the transitive property because we don't have substitution in congruence, okay? So you can go ahead and use the transitive property even if it doesn't connect well. If you can still do that, okay? All right. Any questions on what I did there? Okay. Now, a couple of little theorems, and you'll think that these are all kind of redundant, but they're all a little bit different, stating some information that might be helpful, especially these two, okay? The first one says that perpendicular lines intersect to form 4 right angles. And if you knew that L was perpendicular to M, okay, when 2 lines or 2 rays are perpendicular, they create a right angle. That's what we get from the definition of perpendicular lines. But if you know that 2 lines are perpendicular, then this theorem says not only do you get 1 right angle, but you get 4, okay? So we know that angle 1, angle 2, angle 3, and angle 4 are right angles. I'm going to number these 1, 2, 3. Now, this next one's real important too, because if you know you have a right angle, a pair of right angles, you can say they're congruent without having to go about proving that they both equal 90 and then use substitution and all that. Okay? So if I know I have right angles, then I can say that those right angles are congruent. Okay? That's a good, helpful theorem right there. Now the next ones we don't really use quite as much. Perpendicular lines form congruent adjacent angles. Well, if you go back and look at here, you know, perpendicular lines form 4 right angles, right? Well, right angles are congruent and they are adjacent, okay? So it's kind of common sense. So if you have perpendicular lines You get congruent adjacent angles. The next one, it says if two angles are congruent and supplementary, then each angle is a right angle. Okay? So, let's just use angle 1 and angle 2. If angle 1 is congruent to angle 2 and angle 1 is supplementary to angle 2, so if you have two angles that are congruent and two angles that are supplementary, then angle 1 and angle 2 are right angles. And then this last one says that if two congruent angles form a linear pair, then they are right angles. This one you might use in a couple of proofs here, that 212. But basically this one says, again, if angle 1 is congruent to angle 2 and angle 1 and angle 2 are a linear pair, then angle 1 and angle 2 are right angles. Okay, any questions? All right, so I'm going to pass your worksheet out. You also have a workbook page, so you need to make sure you do that. Now, definitely I take the workbook page home because it's easy, okay? If that's something you won't need any help with. When I pass this out, I would get started on this. That way you can ask me questions, okay? Also, notice on the board, I'm going to omit number 7 and 8 because number 7 and 8 we did in our homework on Friday, okay? So just disregard both of those, all right? And then I want to tell you one more thing about it. Once I get it passed out. Okay, let's look at number 1. You could actually do this in 2 steps, so you don't necessarily need 5. Okay, so you can do that in 2 steps. You can do the long way, but you could probably figure this one out in 2 steps. Number 2 is the one where you're going to use some transitive in there, and probably can use a few symmetric steps in there that aren't accounted for, but you can just go ahead and go straight to transitive without the symmetric steps. That was number 2. And again, we're going to omit 7 and 8. And then you also have the workbook page. The workbook page is more of the algebra type questions, like that we did in that one.